Good day, students. On this clip, we're going to go over how to find the powers and roots of complex numbers in polar form or in rectangular form. Right? So write down the title of this lesson: Finding powers and principal roots of complex numbers. Okay, so what we're going to do, we're going to take a look at two examples. The first one involves finding a power, and the second one involves finding a principal root. So, example one, find 3 minus root 3i to the fourth power. Okay, so we're gonna find this one using De Moivre's theorem. In order to use De Moivre's theorem, we know we need to have it in polar form first, right? And then when we have it in polar form, which is if we have r times cosine theta plus I sine theta, and we have it in this form, raised to the nth power, then all we just do is we raise the radius to the nth power, right, r to the n, and then we're going to multiply each angle by n theta plus I sine n theta. So you multiply the angles by n, and you raise r to the nth power. All right, so let's do this. So to do this one, first thing we're going to do is change it into polar form. So first of all, find the radius. Okay, so r equals the square root of a squared plus b squared. 3 squared is 9. Negative root 3 squared is 3 plus 3, which equals the square root of 12. And that simplifies into 2 root 3. There goes the radius. And theta is the inverse tangent of y over x. So inverse tan of y over x, negative root 3 over 3. Okay. We can do that with a calculator. Inverse tan of y over x. Alright, so plug that into your calculator. Put this in degree mode first, since I would prefer working in degrees. Inverse tan of negative root 3 over 3. Negative 30 degrees. So our theta is negative 30 degrees. So let's rewrite this whole problem in polar form. So it's going to be 3 minus root 3i raised to the fourth power equals 3. Radius is 2 root 3 cosine negative 30 plus I sine negative 30 equals that. Raise the whole thing to the fourth power. Alright, so now we're going to apply De Moivre's theorem. So to do this, we're going to raise the radius or the absolute value to the fourth power, so 2 root 3 to the fourth, and then multiply the angles by 4. So it's going to be negative 30 times 4 plus I sine negative 30 times 4. Okay? Now that gives us, now if we want to expand this, I'm going to have 4 2's, 2 times 2 times 2 times 2, 4 2's times root 3, and 4 root 3's, right? And then that's times cosine negative 120 plus I sine negative 120. Okay? So if I simplify this, 2 times 2 times 2 times, this is going to be 4. And then these two will give us 3 and 3. I'm sorry, this is 16 times 3 times 3. If I do the math, this whole thing comes out to 144. Okay, because this is 3 and this is 3, and that's 9. 9 times 16 is 144. Cosine negative 120 plus I sine negative 120 degrees. Okay, this is the answer in polar form in degrees. What if I wanted to write this as in radian form? Okay, so we'll look at the unit circle. 120 is 2 pi over 3, right? So negative 120 is going to be negative 2 pi over 3. So basically, you could write it like this, or we could write it as 144 cosine negative 2 pi over 3 plus I sine negative 2 pi over 3. Okay? So these are the answers in polar form. This is polar form. This top one is degree, and this bottom one is radius. Any one you put is fine. All right. Okay. So what if I wanted to write this in if I wanted to write this in rectangular form? Okay. I just need to find negative 2 pi over 3 on the unit circle and find the respective coordinates, right? Negative 2 pi over 3. So for that one, let's look at our unit circle. If you look at the unit circle, this is 2 pi over 3 right here. So if we go straight down to this is negative 2 pi over 3. 240 is negative 2 pi over 3. Anytime you have a negative angle, you basically reflect up or down, okay? So we're going to use this coordinate right here. So negative 2 pi over 3 is negative 1/2 and negative root 3 over 2. Okay, so we're going to put it in here. So let me box this one first so I don't get my answers confused. So if I put it in here, it's going to become 144 times, remember the x coordinate is cosine and the y coordinate is sine. It's going to be 144 times negative 1/2 minus root 3 over 2i, like that. All right. So when we distribute 144, we're going to have, let's do it on that side, negative 144 over 2 minus 144 root 3 over 2i. So our final answer is going to be negative 72 minus 72 by 3i. So there goes your answer in rectangular form. So this is rectangular form. Okay? All right. Now we're going to do a real quick write on this whole process. We're going to enumerate our steps. Let's call this step. This is 1, 2, 3, 4, 5. This is line 6. Oh, I think I messed up right there. Did I? No, 6. 7. And this thingy we did right here is 8, 9, 10. So we have 10 steps we're going to do our quick write on. Okay? All right, now let's try another example. Example 2. Find the principal root, cube root of 2 minus 2i and express your answer in rectangular form. Okay? Alright, let's do this. So we're finding the cube root, so we're looking for, we're supposed to find 2 minus 2i to the 1/3, right? So before we can apply the formula for principal cube root, variation of De Moivre's theorem, we have to convert this into polar form. Okay, so we're going to find r and theta. So r is going to be the square root of a squared plus b squared, which is 4a squared plus negative 2 squared is 4. It's going to be the square root of 8, which reduces into 2 root 2. Okay. But I can express this as a fractional exponent, which makes my life easier. So this is the same thing as 2 to the 1 times 2 to the 1/2. If I add 1 and 1/2, I'm going to have 2 to the 3/2. So that's r. Okay? So the problem, we need theta next. Theta is going to be the inverse tan of y, a over b, or y over x. So negative 2 over 2. Inverse tan of that is negative 30, I believe. If we use our calculator, we can verify. Inverse tan of negative 1, which is negative 2 over 2. It's like, ooh, negative 45. My mistake. Negative 45. Okay, sorry about that. So inverse tan of negative 2 over 2 is negative 45. Okay, so now we're going to rewrite this in polar form. Okay, so we're going to have 2 minus 2i raised to the 1/3 equals 2 to the 3 over 2 times cosine negative 45 plus I sine negative 45. All this whole business raised to the 1/3 power. Okay? So how do you apply the formula? All we just do is the radius is raised to the same power, and then the angles is multiplied by the power. Okay, so we're gonna go 2 to the 3 over 3/2. So we're gonna raise it to the 1/3 power. 1/3 right there. Because you have a 1/3 over there. Times cosine negative 45 times 1/3 plus I sine negative 45 times 1/3. What is that? Okay. And that should give us our answer in rectangular form. When I do this, look at this, the 3's cancel out, so you're left with 2 to the 1/2. 2 to the 1/2 cosine negative 15. Because 3 goes into 45 15 times, plus I sine negative 15. And there goes your answer in rectangular, in polar form. Okay? And then to do this, to put this in your calculator, to get this in rectangular form, because 15 degrees is not on your unit circle, okay? It starts from 30. 15 degrees is not there, so we just plug it into our calculator, okay? So to do this, I'm going to do everything in one step. 2 to the 1/2 is the same thing as square root of 2, so I'm going to go square root of 2. Square root of 2 times, open bracket, cosine negative 15, close the angle, plus I sine negative 15, close the angle, close the cosine and sine, enter. It's going to be 1.366 and 0.366, so it's going to approximately be 1.366 minus 0.366. Okay, minus 0.366. So this is polar, and this is rectangular. All right. All right, so that's that for the notes. Now we're going to go ahead and start with the classwork for today.